Welcome. This section we are going to talk about surface area and volume of some three-dimensional shapes. We will use SA for surface area. We will use V for volume. Surface area is the sum of the areas of all the faces of this three-dimensional shape, and the volume is the amount of space inside the shape, inside the object. Surface area is going to be in square units, and volume will be in cubic units, maybe centimeters cubed or inches cubed, meters cubed. We have some pictures of some different three-dimensional objects that we need to be familiar with. We have the rectangular prism, which is just a box. If we have a length, a width, and a height, the volume, let's start with that, it's easiest. Volume is just length times width times height. And if all of those dimensions are, let's say, in centimeters, then I have centimeters times centimeters times centimeters, so I have centimeters cubed. Surface area is the sum of the areas of all these rectangular faces. Length times width is the bottom and the top. Notice I have two of those, 2 times L times W. And then the other ones are just the other rectangular faces. I have width times height. Let me do a different color there. Width times height is that area, but I have two of those. I have this one over here as well. And then I have the front and the back. That are rectangles of dimensions L and H. Okay, so it's not really magic where these are coming from. We're just adding areas of rectangles, and that's going to calculate the surface area. Okay, next one is the triangular prism. It's a little bit more complicated looking. We do have the triangle as the base here, and it's the same size as the triangular base back there. And notice the little dashed lines, those are behind other parts of the object, so we wouldn't really see them. Sometimes they draw them in as a reference. This is the height of the triangular face of this prism. And this is the base. They marked it back here, but we could also mark it right here. For the surface area, we do the area of the 3 rectangular faces, and they'll be side 1 times the length of the prism, and so forth. And then we have the 2 triangular faces. We have 2 times 1/2 BH. That turns into a 1, so I just get BH because we have the 2 triangles here and back there. Okay. The volume, and this is an important fact about prisms. The volume of a prism is always going to be the area of the base times the height or length of the prism. So we take the area of this triangular base and we multiply by the height or the length of the prism, and we get the volume of the prism. Cube is easy. It's just a box where the length, the width, and height are all the same. That simplifies the formulas quite a bit. There's surface area, there's volume. I'm not going to go through that. A cylinder is just like an aluminum can. It has a circular top and a circular bottom, or maybe it's laying on its side, all right? The circle is the base. Circle is the base. And in order to calculate this, now cylinder is not a prism, but the formulas are very closely related. To calculate the volume, we take the area of the circular base and we multiply by the height. So you need the radius and you need the height. Notice they have those labeled. the height, and the radius. Okay, we need to know where to find the pieces that we need to calculate the volume and also to calculate the surface area. Surface area is 2 pi r squared. Pi r squared is the area of the circular top and also the area of the circular bottom. So I have 2 of those. And then the side, the curved part, well, I guess it's all curved. The other part is if I, for instance, cut this straight up and down and then unfolded it, that would be a rectangle, and the area of that rectangle would be 2 pi rh. Okay? And in 12.3, section 12.3, we will do cones and spheres. Now, as it says down here at the bottom, in general, to find the volume of prisms, you find the area of the face or the base, and you multiply it times the height. I'm going to call that the base, because some people say the faces are every flat surface of the prism is a face of the prism. So the area of the base times the height gets us the volume. So we're going to do some examples. I'm going to go through 3 of them here. Find the surface area and the volume of each. So this first one is a rectangular prism. This example 1 right here is a rectangular prism. We have a length, a width, and a height. So the volume will be easy. I'm going to do it first. I'm just going to do the length times the width times the height. I'm going to actually write down the formula. Volume equals L times W times H. And then I just plug in the numbers. 6 times 3 times 10. We grab a calculator and we do that math. Or we do 6 times 3 is 18, times 10 is 180. And we're going to put some units on that. That will be cubic centimeters. Please label your answers with units. Surface area, I'm going to have 2 rectangles that are 6 by 3. I'm going to have 2 rectangles that are 3 by 10. And I'm going to have 2 rectangles that are, what's the other one? 6 by 3, 3 by 10, and 6 by 10. This front one is 6 by 10. Okay, and so is the back one. All right, and then we do that calculation. Oops, almost lost it. We do that calculation, and let's see, what do we have? I need to grab a calculator. 6 times 3 is 18. 3 times 10 is 30. 6 times 10 is 60. So what I have 90. 108 times 2, 216 square centimeters. That is what we have. Square centimeters. That is the surface area. Okay. Next one we're going to do is the triangular prism. Now, we are going to decipher this. We have a triangular base on the top and the same size triangular base on the bottom. This is a little dashed line. That is 3 meters. This one right here is 4 meters. This one is 4 because it matches this one down here. So we have to understand how those diagrams fit together. And now we're just going to calculate volume. So to calculate the volume, I need to identify some things here. So the triangular base has a whoops, is that a 4? I have to be careful. That's not the one I want. I want this one right here. That's where I've drawn the perpendicular. So the height of the triangular base is 2.8 meters, and that's a, how big is that one? That's a 4. This one up here is a 4. The one below it is also a 4. So that's a 4. Okay. And then the height of the triangular prism is 3. Or should I call it the length? Length. Okay. So for the volume, we're going to do B times H divided by 2. And then we're going to multiply that with L. And you could put all this together over a 2 if you wanted. That's the way fractions work. I just do 4 times 2.8 times 3. That whole thing divided by 2 if I wanted to. And I'm just going to let you do that calculation. Right? Just grab a calculator, figure it out, and whatever it is, it will be meters cubed. At this point, it's just some calculator work. Okay? Surface area for this one. Surface area is going to be, I'm going to have, let's see, I have a rectangular face right there. That's going to be 4 times 3. I'm going to have another 4 times 3, which is right there. And then I'm going to have a 3 times 3 over here. And then I'm going to have the triangular top and bottom. And they are, I have 2 of them, so that's the BH, which is 4 times 2.8. Again, we grab a calculator. We do the computation, and we have meters squared. Okay? And you can work that out. It's pretty easy. You just plug the numbers into the calculator. Okay? That's what we're going to come up with. Okay, the next one. We are looking at a cylinder. This time we have a cylinder. Now what I need you to understand is the diameter of that cylinder is 20 yards. 20 yards. That would mean the radius is 10 yards. Remember, to find the radius, we just chop the diameter in half. So if the diameter is 20, that would mean the radius is 10. Okay? Next, we're going to identify this as the height. That's the height of my cylinder. How do we calculate volume? Volume of the cylinder is pi r squared h, and now I'm just going to plug in the numbers. If you find it helpful, write down the formula on paper and then plug in the numbers, right? So the volume is going to be pi times 10 squared times 5. And once again, we just grabbed our calculator. Oh, one thing I did want to talk about is some of the problems in the homework ask you to give an exact answer in terms of pi. If that's the case, you would just do the 10 squared, which is 100, times the 5, which is 500. 500 pi yards cubed would be the exact answer in terms of pi. And then in order to find the decimal approximation, to find it rounded to, let's say, 2 or 3 or however many decimal places, you just either use the pi button on the calculator and do 500 times pi, or if the instructions tell you to use 3.14 for pi, you just do 500 times 3.14. So read the directions. It will tell you how it wants you to calculate it. I'm just going to write it in terms of pi, and you can do the computation with the calculator. So surface area, formula for surface area is 2 pi r squared. So we're going to do 2 pi r squared. Two pi r is 5. Ooh, r is 10. We have 2 pi r squared. And then we're going to add 2 pi r, which is 10, h, which is 5. Plug the numbers in the right places. Okay? If we need an exact answer in terms of pi, we will do 10 squared, which is 100, times 2. So we'd have 200 pi plus, let's see, 5 times 10 is 50 times 2 is 100, so I'd have 100 pi. And then I can add these two together. It's like adding 200x and 100x, I get 300x, but it's a pi instead of an x. So 300 pi, and that would be square yards. And if you needed a decimal answer, you either do 300 times pi using the pi feature of the calculator, or you use 3.14 for pi if they tell you. If they don't tell you to use 3.14 for pi, use the pi feature on the calculator. All right, now for the notes.